Hey everyone, welcome back to the bench. Today we're going to take a look at this little constant current LED driver rated 350 milliamps. Each square on this little platform is 1 centimeter, so you can see how small this thing is. It's roughly 2 by 1 centimeters. It operates with an input voltage from 5 to 28 volts, and of course your red lead is your positive. On the output side, your orange lead is the positive. It's made by LED Dynamics, called the Lux Drive, 350 milliamp Bucktoot. Gotta love that name. And what do you see here at the bottom? Yes, it's actually made in the USA. Imagine that, electronic product made in the USA. And it's fully potted to protect it from harsh environments. So it's very small, fully potted case with includes the leads. So you could tuck this in a tight application for your LED project. I bought this from DigiKey for $9.49. You might say, yeah, that's kind of expensive. But this is a nice quality product made in the USA. I would expect at least that it would last for a very long time. And having it fully potted to me is a real big plus. So what I'm going to do now is hook it up to my power supply and an LED and take some measurements. I've connected my power supply up to the driver, just using this socket board as a jumper. Ignore these components, they are not part of the circuit. In series with the output, I have my meter to measure the output current, see how the regulation is. And I'm using this 9 volt Cree CXA 1304 LED on the output. It should be a very good match for that driver. Okay, I have the voltage set at 12 volts, and I'll turn the output on. You can see off to the side the LED came on, and the input current is 320 milliamps. You can see the LED is nice and blindingly bright there. Okay, so our output current is 361 milliamps. Now I will measure the dropout voltage. The LED is running at 9.7 volts, so I will decrease the current, and let's see, starting to drop out. See how it's getting lower there? So let me go back up. Okay, so our input voltage is 10.6 volts and our LED voltage is 9.7. So it's a little over a volt until the current starts dropping out. The datasheet said it was 2 volts, so that's probably a maximum. And at least in this application, we have a pretty good dropout voltage of only 1.1 volt. Now I'm taking the voltage down. Take it down to 9 volts. And the LED is still lit, though a lot dimmer, and our current's about 120 milliamps. Now let's go the other way. I'll take it up to 18 volts. You can see we went back into current regulation there. And 18 volts. So now we're at 18 volts. You can see the input current has dropped to 220 milliamps. That is because, being a constant current switch mode regulator, input current will naturally drop to keep the power the same. And it's rated to go up to 28 volts, so we'll go all the way up. 28 volts. And it's still regulating the current pretty well. And the current on the input has dropped to 150 milliamps. So the little Bucktoot is doing its job. One limitation of this model, it only comes in 350 milliamps. But they do have an AC input version that is somewhat longer, and it comes in a 350, 500, or 700 milliamp version. So that gives you some opportunities there. One thing you have to remember that this is a buck type regulator, so you have to use a supply voltage that's higher than the forward voltage of the LEDs that you're using. So in my case, I was using that 9 volt Cree CXA1304 and operating it with a 12 volt supply. And of course, it could be 12 volts, it could be 18 or even 24 volts to drive that 9 volt LED at a constant current. I can see a lot of applications for this thing, from automotive to solar. I'm certainly going to put it to good use. That's it. Thanks for watching.